Hi, I'm Luke Kane, and welcome back to Algebra 1. Today we're going to talk about dividing rational expressions. Essentially, a rational expression is a fraction, or a ratio, if you will, divided by a ratio. And it turns out this is really nothing new in algebra because it's a technique that you learned back in elementary school when these were just fractions. And basically the trick is you take the division problem, you take the dividend and you copy it. Then you change the division sign to a multiplication sign. Then you take the divisor, which is the number that appears after the division sign, and you flip it. And then you multiply, as you've learned before, you multiply numerators times numerators and denominators times denominators. So in this case you get A times D equals AD, and B times C equals BC. Let's do a couple of examples. Here we have two division problems. This one is labeled A. I know it's hard to see on your screen. And this one is labeled B. They are both division problems that involve rational expressions. We have a rational expression divided by a rational expression. Well, we can just think of that as a fraction divided by a fraction. And the rule is pretty straightforward. We take the dividend, which is just the term dividend, which is just the term in front of the division sign. That's this guy, right? We just copy it. Dividend with a D, not with a T. If I learn how to spell, I'll be deadly. And we just copy that. 42y to the 10th over z to the 4th. All right, now we take the division sign and we make that a multiplication sign. And now we're going to invert the divisor. This is the divisor, and we're going to invert it or flip it. That means we're going to take the denominator and we're going to make it the numerator. So that becomes z to the 6th. And we're going to take the numerator and make it the denominator. They're going to effectively change places. That's a 7, not a z. That's pretty obscure. 7 y squared, right? All right, now since we have multiplication, all right, it's multiplication here, we can now factor out all these terms because these terms are now all factors, because that's what definition of factor is some term multiplied by another term and so on. So since we know that, we can now factor this out. So let's look. What do we have for common terms? We have z to the 4th. All right? Right here. Z to the 4th over z to the 4th is just 1. So it effectively cancels. So if we divide this by z to the 4th, that's going to go away, and it's going to become 1. Okay. So now we have to do the same thing to the numerator, and we've got z to the 6th. We divide it by our common term, which is z to the 4th. All right, that's going to be z, has the same base, 6 minus 4, which is z squared. So that's going to be a 2. All right, let me just clean this mess up a little, because I need the space. Okay. And let's continue on. I can factor out the 7. 7 goes into 7 once. 7 goes into 42 6 times. And I've got y squared. Y squared divided by y squared is effectively 1. And now I've got y to the 10th divided by y squared. That's going to be 10 minus 2, which is 8. All right. So now I multiply numerators times numerators and denominators times denominators. And what do I have? I have 6y to the 8th times z squared. And in the denominator, I have 1 times 1 times 1, so I can ignore it since the denominator is just 1. Doesn't add anything. It's just, it's not necessary. So this becomes what we end up with after we multiply these two fractions. All right, let's look at this term here. this problem here. This one, yeah, we have a fraction, but it's not divided by a fraction. All right, so we make it a fraction. All right, we take a problem we don't know how to do, and we make it into a problem we do know how to do by just simply dividing by 1. All right, we haven't really changed anything. Just demonstrating that this really is a rational expression. And it's the same deal. We take the dividend and we just copy it. P squared minus 5p minus 24 over p cubed. All right, we take the division sign and we make it a multiplication sign. And now we're going to flip. So it's a good thing we put the 1 there. So now I know what to put in the numerator. So the denominator now becomes the numerator. And the numerator is now going to become the denominator. So that's going to be the quantity p minus 8 squared. All right, since we're dealing with multiplication, all right, we have a trinomial times a monomial technically. But we have, these are all terms that are multiplied, so we can now factor. All right, do not try to factor this p into the p. This is not multiplication. This is a subtraction problem, and if you try and factor across that, I will come and hit you with a stick wherever you are. Do not do that. But I can multiply, or I can factor out this whole term if it has a common factor with this whole term. And that's what I'm going to hope for by factoring this. So I can factor this for this trinomial into the product of two monomials. All right, my initial coefficient is 1, so that tells me that my initial term for both of these binomials is going to be p, because p times p is going to equal p squared. All right, now when I multiply these two terms together, I got to get a minus 24. All right, how's that going to happen? I multiply two numbers together and I get a minus sign. Well, that means the two numbers have to be, one has to be positive and the other has to be negative. When I multiply them, the product is 24. But when I add them, when I multiply them, the product is minus 24. That's important that we get the sign right. When we add them, the sum is minus 5. Well, we think about that for a while and we realize, well, the numbers minus 8 and plus 3 should work, because plus 3 times minus 8 is minus 24, and plus 3 minus 8 is now minus 5. So that's going to work over p cubed, and of course it's just equaling the top. And now we copy this thing over again. All right, and now it's clear we still have factors. Aha! This divided by itself is 1, so that goes away. This divided by the quantity p minus 8 is just p minus 8. Okay, and is there anything else we can do? No, that's about it. So we end up with p plus 3 over the quantity p cubed times p minus 8. All right. Now, do not try to do anything here. This is an addition sign. This has to be multiplication if you're going to factor out. So we cannot factor anymore. There are no more common terms to be factored out. So this is what we get when we divide that. Okay, what did we learn? Well, we learned how to do division of a fraction by a fraction, where we had the form a over b divided by c over d. Basically, the technique was to copy the dividend. We just leave the dividend as it was, a over b. And the next thing we do is we change this division sign into a multiplication sign. Then we take the divisor and we flip it. Now we just do the multiplication. A times d equals AD, b times c equals BC. And that's pretty much all there is to division of a fraction by a fraction. Next time we're going to look at a slight variation on this theme. We're going to look at how to deal with complex fractions, which are fractions in which the numerator is a fraction and the denominator in fraction. Till then, I'm Luke Kane. Thanks for watching. Bye now.